transmission angle. Okay. So transmission angle generally we denote by mu. Generally we denote by mu. Okay. So इसमें लिखो it is the angle between output link and coupler. It is the angle between output link and coupler. ठीक है. So let's say this is any general 4-bar mechanism. Any general 4-bar mechanism. Link 1, link 2, link 3, link 4. Okay. So here let I am giving name A, B, C and D. A, B, C and D. This is our input link. Link 2 is our input link. Okay. So we will provide torque here. We will provide torque here at the input link. So link 2 is our input link. Okay. So when we will apply torque here, this link will apply some force like this. In that some force will go along the third link and some force will go away from the third link. Okay. So the force will be transferred by the link 2 on the link 3. Then link 3 will apply force on the link 4. Yes or no? Then link 4 will start rotating. So here you will get the output torque. This is your output link. So output torque will be obtained here. Okay. So here it will be omega I also, and here it will be omega O also, omega output. Clear? Let's say the length of this link is D. Length of this link is D and it is called fixed link. Okay. Length of this link is A. Length of this link is A and it is your crank because it will be moving complete rotation. So it will be A. And here let's say this is the coupler and coupler length is let's say B. Okay. Coupler length let's say B. And this length of output link is C. Like this. Length of output link is C. Like this. Okay. Angle of this crank we will consider as theta with the fixed link. Theta with the fixed link. The angle between crank and the coupler is gamma. Okay. Now the angle between coupler and output link will be your transmission angle. So this is actually transmission angle mu. Okay. So this transmission angle is here. Clear? Transmission angle is the angle between output link and coupler. Okay. Link B is coupler. Now here this mechanism can be of different type, like crank mechanism, crank rocker mechanism or rocker mechanism. How to find that? That we simply know we can apply the Grashof rule. Grashof rule. Okay. Now here when we apply the torque at the input link, the force will be applied on this. Then this force will come here and due to this force this link will start rotating and torque will be applied at the output link. Yes or no? Now for any value of the force when it will be continuously moving, mechanism will be continuously moving, the value of forces will be continuously changing. Yes or no? Value of forces will be continuously changing in all the links. Okay. And direction of forces will also change always in the links, because this is totally dynamic analysis. Yes or no? All links are in motion. But but for any link, but for any link, at any instant, the value of torque can be maximum only when the force applied on the link is at 90 degree. Yes or no? Whatever the value of force, but maximum torque will be obtained only when this will be equal to 90. Yes or no? So if I am talking about our output link, अपने को आउटपुट मैक्सिमम चाहिए होगा, मिनिमम मैक्सिमम आउटपुट वी वांट. ओके, हमें मैक्सिमम आउटपुट मिलना चाहिए. So for the maximum output means maximum torque, the F should be acting at 90 degree. Okay, but this angle will not be constant. Continuously links will be moving and angle will be changing, value of force will be changing, so torque will be changing, output torque will be changing. Okay, now our aim is here to get the maximum output, so we will design this mechanism in such a way that we keep this angle near 80. Sometime it will go little more than, not 80, 90, little more than 90 and little less than 90. Let's say we try to move or keep this angle in the range of, let's say, 85 degree to 95 degree. So in between always it will be passing through the 90. Okay, so you can write here, for any value, for any value of the force, for any value of the force in the coupler, it will transmit maximum torque, it will transfer maximum torque when the mu will be 90, when mu will be 90. So we design the mechanism in such a way, that mu is found varying near to 90. So when mu will be varying near to 90, that mechanism will be giving us maximum output at most of the time of running. Okay, so we try to keep this value near 90. Maybe it is happening or not, that is different issue, but if it will be near 90, then our mechanism will give maximum output torque for maximum time of running. Yes or no? Okay, now here theta is the angle of input link. So this will be like our angle of input link, input variable type. Okay, angle of input link, this we have to control, and mu is related to the angle of output link, angle of output link. Okay, so we will try to find the value of mu in terms of theta, or we want to check how mu will be varying with respect to theta, Okay,